So hey everyone, hope you're doing well. My name is Rahul Paul and welcome to my channel satmathprep. And today we are going to discuss the next part of the exponent theory. In the last class or in the last video, I have discussed about the first two rules of the exponents, that is the product rule and the quotient rule. So today we are going to start with the third rule of the exponent. So we are discussing law of exponents. So we are going to discuss with the third law of exponent, which is known as the power rule. Okay, so what does the power rule say? The power rule says that, let us say we have an exponent a to the power m. We have an exponential expression a to the power m. Now when I am powering that power, that means on that particular exponential expression, we are treating that exponential expression as a base, and then we are powering that particular base. So let's say I'm powering that with n, for example. So in that case, what will happen? In that case, we will be multiplying the exponents and we'll be writing a to the power of mn or a to the power of nm, both the same thing. Okay, so that is the power rule, and this is not just limited to multiplying two exponents. Let's say if we have a raised to the power m raised to the power n raised to the power p and so on. So in that case also we can write a to the power of m and p, or a to the power of n mp or pmn, or whatever combinations we can make. So this is about the power rule. This is rule number 3. Next, we go to the next rule number 4. So in rule number 4, we will talk about the exponent zero rule. Exponent zero rule. So the exponent zero rule is just a very simple thing which says that no matter what the base is, your base can be a negative number, your base can be a positive number, your base can be an integer, your base can be a fraction, your base can be square root, cube root, fourth root, fifth root, whatever the base is. Whatever the base is. In fact, if the base is also a variable, whatever the base is, if you power it up with 0, the result shall be 1. Okay, the result shall be 1. So it's a very important tool, because since the powering of 0 gives 1, so no matter the base is, the result becomes 1. So we can channel the base based on our own requirement in the question. So this is a very important rule in exponents, and it helps us in a lot of ways, which we will see later on. Next, we will talk about the next rule. The next rule is the negative exponent rule. The negative exponent rule. Now, what is the negative exponent rule? So, from the name itself, you can clearly get the idea that we are talking about negative exponents. Now, what happens when we have negative exponents? So, when we have negative exponent, let's say we have a raised to the power of negative m. So, when we have a negative exponent, what will be done is, if we want to make that negative exponent turn to a positive exponent, so in that case, we need to just reciprocate the base. That's all. When we reciprocate the base, automatically the negative effect is gone. The negative becomes positive. Now let's say if I have already a positive base, and if I reciprocate the base, if I have an already positive exponent and if I reciprocate the base, in that case that exponent will turn to be negative. Okay, so this is like exchanging the sign of the exponent. If you want to exchange the sign of the exponent based on your own requirement in the question, you just simply have to reciprocate the bases. If the base is an integer, you will make 1 by that integer after reciprocating, and if the base is a fraction like p by q, then you can easily make it q by p. Okay, so this is negative exponent rule. This is rule number 5. The next rule is a very important rule. The next rule is about the rational exponent rule. The rational exponent rule. Now see, rational exponent is actually a classification of the basic exponents where the exponential expression has an exponent which is in the form of a rational number, or simply to put in terms, which is in the form of a fraction. So whenever an exponential expression has an exponent in the form of a fraction, we call it a rational exponent. Let us say a raised to the power of m by n, for example. So a raised to the power of m by n is known as a rational exponent because m by n here is a rational exponent. Okay, this is a rational exponent. Now, whenever we have a rational exponent, there is an alternate form which can be utilized in order to do problems for exponents. Okay, so that form is known as a surd or a radical. So you can simply convert an exponential expression with a rational exponent into a radical. And how to do that? So all you need to do is you can write a to the power of m by n, and what will be the radical form of that? So we will take the nth root. Remember, what is nth root? N is the denominator, so whichever is the denominator, that root will be the radical, and then in the root you will put the base, and overall you will put the power. If you want, you can also put the power on the base, that also can work. Okay, so that depends on the question, that depends on the requirement. Based on that, you can decide whether you want to put the power with a or you want to put the power overall. Okay, both are correct, both will give you the exact same answer. So this form, this particular form is known as radical form. This particular form is known as the radical form. Okay, similarly, from radical form, if we want, we can turn it back to the exponential form. So all you need to do is whatever the root is, that becomes the denominator of the exponent. Whatever the power is, that becomes the numerator of the exponent, and the base is obviously the base. Okay, so this is how we are going to convert a rational exponent into a radical and a radical back into a rational exponent. Some of the very commonly used things like a to the power of 1 by 2. So you can simply write it as square root of 2. Normally, sorry, square root of a, my bad, square root of a. Normally, you should write 2 second root of a to the power of 1, but then again you can understand power of 1 doesn't make any impact on the value of the answer, so we can just ignore it. And also second root means square root, and square root is by default 2. We do not need to put a 2 over here, so therefore we can just simply write a root of a. Now let's say if a has a power of 1/4. Now in that case you have to write the root, fourth root of a. Then again, giving a power of 1 doesn't matter. Okay, so this is how we are writing the rational exponent into the surd or the radical, and radical back into the rational exponent. Okay, so in this video today, initially we have discussed about the power rule. What is a power rule? Whenever an exponential expression is itself the base and that is powered by another power, in that case you can multiply the powers and you can use the power rule. Okay, and it can be not only for two exponents, it can be for multiple endless exponents. Then comes exponent zero rule, where the value, no matter the value of the base, if the exponent is 0, the answer will be 1. Negative exponent rule says that if you want to change the sign of the exponent from negative to positive or positive to negative, you have to reciprocate the base. If the base is an integer, make it 1 by integer. If it is a fraction, make it like p by q. If it is in the form of p by q, make it q by p, right? And finally, the rational exponent rule, which we have already discussed so far. A rational exponent is when the exponent is in the form of a fraction, and we can convert the rational exponent or a rational expression into the surd or the radical expression, how we can do, I've already demonstrated, and some of the examples I've also given so that you can understand. Okay, so with that we will conclude the video, and on the next class we are going to discuss a little more a theory about the exponents, specifically how they are used in the equations, and we are going to start with some applications, some very good application of exponent. Okay, so please stay tuned, and if you like this video and if you like this channel, please subscribe, and I'll see you on the next video. Until then, take care.